So today our job is to represent the average annual rainfall at each district of Tripura with the help of GIS software. So let us assume, as you can see from the map of Tripura, that there are 9 districts: South Tripura, Supai Jala, West Tripura, Kowai, Dalai, Unamputi, North Tripura, Gomti. Right? Sorry, there is 8 districts in Tripura, and we have to show the average annual rainfall for these 8 districts on the map of Tripura. Right? So we decide that we will use different colors to show the average annual rainfall of each district of Tripura. So our first step will be to open MapWindow software. If you do not have this software, download it from mapwindow.org, and then we will import this map. And before importing, we need to change the coordinates system of the map from the settings tab. Right? Next, what we'll do is we'll create a polygon shapefile, right? And create a attribute table where each row will represent each district, and there will be 3 columns in that table. One is the serial number, followed by name of the district, and lastly annual average rainfall. So the attribute table have in total 9 rows, because 1 row will be for heading. So there will be 8 rows plus 1 row for heading. Right? And there will be 3 columns: 1 column for serial number, 1 column for name, and 1 column for AAR. That is the average annual rainfall. Now, after doing all this, we have to digitize all this district. Okay, we have to digitize the district, and then we will select the property tab. Then we will select the properties tab by right clicking on the polygon shapefile that we have created for representing the AAR. Properties, you say the properties, and then color scale or color. So let us see how it is done with the help of a hands-on video from MapWindow or the working with the MapWindow software. So at first what we'll do is we will download the MapWindow software from mapwindow.org. Then after downloading the software, you will install it in your computer, and after that this logo will come up, and if you double click on the logo, this will be the opening framework, starting framework. This is your toolbox. These are all the tabs. So our first job will be to apply the projection system, coordinate system of this one. So we will go to map, then to map projection, and as these are all the different types of projected coordinate system available in this software. We will select WGS 84. So this coordinate was this coordinate system, projected coordinate system was developed in the year of 1984, and it is mainly used in European countries, but you can use it here also. So we'll select this WGS 84 world marketer and then click on OK. Right. Now what we'll do is we will import the background map of Tripura. So for importing this, you have to go to add raster layer, then select the map here, open it. It will ask that as that map was, or that map has no projection system, so that is why it will show a projection mismatch download, because in the software the projection is WGS 84, but for the image there is no projection. So what we'll do is just click reproject. Okay. So once you reproject it, what you will do is you will again go to this map, then you click OK and open it. So this time you just click ignore. What will happen is the map will be shown here. Okay. Now do not if we ignore the accuracy level of the latitude longitude, because we are using the WGS 84 and Tripura is situated in northern hemisphere, and maybe there will be large amount of mismatch, but it can be ignorable in the present case. So what we will do is next step will be, so first step is to fix the projection system. Then the second step is to import the background layer, the background map, by clicking on add raster layer and selecting the map image. And the third thing is to create the shapefile through which we will digitize each district. So click on this, name this layer as district underscore rainfall, because we will represent the rainfall only. And layer type or shapefile type, select it as polygon. All other things you keep it as it is. Now save it in your favorite folder. Any folder you like, you can save it. So here what we'll do is we'll save it in my favorite folder, this one, GIS tutor text. So we are okay that shapefile. So this is actually the what container of the shapefile. Now we have to create the polygon shape. Select this add geometry, click on add geometry and start to digitize. So here I will hurriedly digitize all the district. This is the West Tripura district that I am digitizing. Just click on the boundary and go on digitizing. So I think the digitization will not be very accurate because I will hurriedly go through it. After you finish the digitization, just right click and click finish operation. Click and OK. Now let us digitize the second one. Here also again finish operation. Yes. Then the third one. So please don't look much about the accuracy level of this digitization. Just go on. Guys, this is actually a demo which is trying to show you how you can represent the annual average rainfall for each of the district of the state through a GIS. So here also you do this finish operation. Click 3 districts digitized. Now in the fourth there are total 8 districts. So I am quickly going to the pattern. So go on doing this. Although when you are doing it in real life problems, be very accurate with your digitization. Finish operation. Right, so this 5 is covered. Now the last 3, let me digitize very hurriedly. Don't worry, we can edit this digitization later on. Here we are just right. Now the remaining 2, let us move very fast. This is the Gomati district. So what happened here is we have overlap. What happened? We have just the starting point and the finishing point has become the same. So that is why this error was shown. So again there is error. So what we will do is try to do it again. What we'll do is we'll click escape and redigitize the district. Although there are other methods here by which you can rectify or edit the digitization. Here our objective is something else, and that is why I will not go to that. But Now let us see what this is. The last district, South Tripura. So here also we have. So our digitization is over. Now what we'll do is we'll create a table. We'll open the table editor or the attribute table to store the rainfall values of each of the districts. So we'll right click on the polygon shape file and go to table editor. Here you see this will be the default column as we have digitized 8 districts 8 times. So there are 8 number of rows here, and we'll add 2 more fields. One field is for name of the district, and the name of the district is always string, that means letters, and then we can add field again and use this as the AAR, that is the rainfall, average annual rainfall of each of the district. And this is nearly, you will use double because generally these rainfalls are in fraction. So this string is for storing letters only, this integer is for storing integers only, no fraction. This double is for storing integer as well as fraction. Boolean is yes or no, date and time is self-explanatory. Either you can store date or you can store time. Here I will select the double. With 20 means I can store a number, a fraction of 20 digit before the decimal, and precision 10 means 10 digit after the decimal. So these can be reduced to 3 if you wish, or any value. So all this name and AR is, these fields are created. So this is a 3 column. First column is by default created when you digitize all the district by the polygon shape file. Then you have created these 2 columns, name and AR. So let us store them. So whenever you select the row, the corresponding polygon shape file will be highlighted. So first it is better to turn off, take off the polygon shape file, see the name of the district, it is West Tripura. So we write it like this, West and AR, this is an imaginary value. Still, let us say the AR is 75, either in millimeters or anything choice. Next is another one. First row, let us click it. Here you see that corresponding polygon shape file is highlighted. Turn off, this is quiet. If the name is OI, we have a average annual rainfall of 45 millimeters. So these are all assumed value. Again turn on, then select the row, corresponding shape file will be highlighted, and I think this is your data. Let us give the AR a little bit high because let us say 100. Now let us select the 4th row, this one, Kuno Footy. Let me see this as Kuno Footy. And yes, little less than the line. Again you turn on, select the row, corresponding shape file will be highlighted. Turn it off, it is not. So in this way we can enter the data related to the shape files, right? Then again you go for this, select the fifth one here, sixth one. So sixth one is this one. Don't let us give it this one and also have very good rainfall, 85. And lastly, let us say the last shape and South Tripura. So the South Tripura, good amount of rainfall. So the data entry part is finished. Now let us again bring it to the earlier zoom. So if you click on this tab, zoom to maximum extent, the map will be focused in the central position of the frame, this window, the software. Now let us, our next work job is to represent this AR with the help of this digitized polygon file. So I am clicking on, right clicking and selecting the properties. In the properties, you will go for categories. So we want to depict the annual average rainfall through this GIS map. So that is why we select the field AAR, this color, AAR. We'll select the color scheme, any color you can select. Okay. Use random colors, or you can use this gradient. Anything. Okay. So let us categorize this map into 8 categories, or you can select only unique values. Okay. So if you select unique values, you select random colors and click generate. Okay. So before that, again, okay, right. So these are random colors representing different AAR. Click on apply, click OK, and you have your thoroughpath map depicting the rainfall of each district by a distinct or by a separate color. Right. So here, another thing you can do. What you can do is, with the help of the AAR, here you see for that unique color, unique value, we are using different color for different rainfall, right? So that is why I have used unique values, and I have selected the column name for representing the AAR, because each AAR will have its own color. But if I want to represent the AAR with the help of 3 different categories, right? One category is high rainfall, another one is medium rainfall, another one is low rainfall. Then what we will do is, first we will take off the unique values, take off the random color, use a gradient, 3 categories required. So I place it as 3 categories, number of categories 3, select the AR field, click on the generate, here you see, right? So easily you can understand 45 to 56 is the lowest value, 256. 3 number of data, 3 number of district has this value, falls in this range. Red is representing the lowest rainfall, green medium rainfall, and this blue highest rainfall. Right? You can change the color if you wish. You can use this green color also or blue color, whatever you may. Right, so you can change this color as I was discussing. So you can change the field type also. You can use this solid blue color and click OK. That is also possible. Whatever you can change it any time, any way you wish. Now you click apply and you click OK. You see, with the help of this map, I can say there is the index that this and this district has the lowest rainfall. These three districts has the medium range rainfall, and these two districts has the highest rainfall. Right. So this is actually, you are seeing some different color, but it is actually because it is already selected. So you just click on selection and remove selection. So you can just, you see, whatever row you select, corresponding polygon shapefile will be highlighted. So here you see that right. So here it is. You can see as usual that this is the way more or less you can represent each of the district with respect to its corresponding rainfall. So is this is what our objective of our job is. So these are the districts and these are its choropath map showing the rainfall in three different categories. This I